They do, but this is cheaper than that. Okay, so Charles Darwin is the one that most people associate with all the work in evolution. And he was the main one in there, but he certainly did not work alone in there. In 1859, he published his book, Origin of the Species by Means of Natural Selection. And that's where a lot of the things are based on. And there's two main points in that work. One is that all the contemporary species that we have today arose from common ancestors, that basically it was descent with modifications. So you descended from those ancestors and you changed a little bit as you went in there. And it happened by natural selection. And what natural selection basically says is that in the natural environment, there's going to be certain traits that are better adapted for survival, and those are going to be more likely to be passed on because you're more likely to get a mate and breed. If you don't have good traits, you're less likely to get a mate in there and breed. And so when you look in the animal world, for the most part, you see that quite a bit in there with like birds and things like that. They're real picky about the other one. You've got to have pretty color feathers. You've got to be the strong looking one. If you're the bird that, you know, lost all his feathers and stuff, you're probably not going to get a mate in there. And so your traits don't likely get passed on in there. He made 3 observations that individuals in a population have variations in traits. So we all have eyes, but all of our eyes look slightly different in there. A population can produce far more offspring than will survive to produce their own offspring. So when you look in us and in the animal world, you'll create a lot more offspring that will end up growing and developing to produce their own offspring. So if you look at rabbits, you know, they're going to produce new bunnies every 6 weeks or so, and not all of those bunnies grow up to be adult bunnies. A lot of them die in the process in there. And then a species is adapted to its environment, and when it is, it's more likely to survive. So it just infers that those that are better adapted are going to be more likely to survive in the long run. So he did some studies where he looked at birds and their different types of beaks, and if they had the right kind of beak for eating the food that was in that area, they were going to be more likely to survive. So looking at scientific study and inquiry, this is the scientific method, which hopefully you've had this before. I know that if you're recently out of high school, you've had this. If it's been a while, you may not have. So science is our way of understanding the natural world, and inquiry is just the search for looking for information and how to explain it in there. And so when we study science, we make a lot of observations in there, and once we've looked and made these observations, we come up with hypotheses in there. We try to come up with a reasonable explanation for it, and then we test it. A lot of times people will kind of assume that a hypothesis is just random in there, that somebody just comes up with an idea. And in reality, that's not the case, because it costs money to test things, and nobody is going to fund you to test something if you don't have a fair amount of background information behind it that your idea is probably going to be right or wrong to justify doing the test in there. Most of the time, researchers are not paying for their own research. There's somebody else in there that's going to want to see your data along the way in order to keep funding it in there. So observation is just using your senses to gather information. Whenever possible, you try and record the data in there. It can be either qualitative or quantitative. Qualitative is going to give more of descriptions rather than numerical, where quantitative is going to have numerical measured data. Whenever possible, you want to try and have your quantitative data in there. It's hard to argue with hard numbers. We can put up a color on the board, so I can put this up on here, and I can say, you know, what color is that? For some people, you're going to say green. Some people are going to say, no, that's like grass green or Kelly green, and everybody's going to have a slightly different description of it, which makes it more difficult with qualitative things, where if there is a number 4 up on the board, it's number 4. It doesn't matter where you came from, it's a number 4. in there. So there's less argument and confusion with that. It uses inductive reasoning. So it derives generalizations from a large number of specific observations rather than trying to apply the generalizations to explain specifics in there. So there's just kind of an order that you go about doing things. That first chapter in your lab manual has you going through doing these activities in there and writing that up, doing the practice on there. If you feel like you need more practice on some of these things than what the lab manual gives you, let me know, because I do have a lot of other worksheets. They're for my high school class, but I've had the college classes say they found them helpful to use too in there. I can't necessarily print out more of them. High school students aren't supposed to have to pay for their own stuff where you guys are. So that's, but I can give you the website where I have them all, so you can go on and look for them if you would like. So we use the scientific method quite a bit, but there are some things that science can't address in there. It has to be testable. If there's no way of testing it, science can't explain it. It has to be falsifiable. We have to come up with a definite definition of what we would say is not true in there. And then your supernatural things like religion, personal faith, a lot of stuff with human emotions. Science does not do real well explaining that in there either. So the scientific method is your idealized process of inquiry, but you end up using some flexibility in there to actually make it work. You just want whatever you study to be repeatable by another person. When you design a study, you're going to have an experimental group. They're going to be the ones that receive a test or manipulation in there. A control group, they're not going to receive the test or manipulation. They're used as a basis for comparison. So if you want to know if a drug works, you also want to be able to compare it to some people who didn't take it so that you know it was actually the drug that caused the change, not something else that they were both exposed to in there. You want to keep the experiment controlled. The more you can have things set up in a specific way and define where they're going, the better off you're going to be. So you want to have an experimental group and a definite control group in there. You don't want them mixing. It isn't that one day you come in and you're part of the experimental group, the next day you're part of the other group. It needs to be defined which group you are part of. You also need to look at the variables or the other factors in the environment. Ideally, you want to keep as many of the factors the same and only look at what you're testing being the only difference in there. In reality, that's kind of hard to do, especially when you're dealing with humans. If you're testing mice, it's not really that big a deal. You put the mice in a cage, they don't really have any control. You feed them all the same thing, you give them all the same amount of water. That's the way it goes. With humans, if you were to test a drug, once a human goes home, you don't, if you're testing, say, a weight loss drug, and you go, okay, this person lost all kinds of weight, this person didn't. One of the people raided a Twinkie factory before they came in and did your study. The others, they only eat apples and fruits and vegetables in there. That's not really going to be a good comparison to see if your weight loss drug worked in there. You need to have all other factors be the same. And it's really hard to do that unless you have humans go into a controlled environment. So a lot of times you'll see with studies, they advertise them on the radio and TV that you'll get paid to participate in this study in there. They'll ask you, you come stay in the facility. That way everybody's sleeping in the same kind of environment. Everybody gets the same food. Everybody sleeps the same hours, does the same activity in there. Even that's going to be hard to give you a good picture throughout society, because if you look at the idea of you're going to get paid less than minimum wage to do this, you go live in a place that somebody's going to tell you what you eat, when you shower, all of those kinds of things. It's kind of like being in jail. So most people don't really want to sign up for that. If you're really hard up for money, then you tend to see people will be willing to sign up for that. But that's also going to not necessarily give you an even slice of the population in there. So you tend to see sometimes, I know there's a fair number of people that will do that in order to acquire other drugs in there. That's not going to give you a good, even slice of the population to see how well a study works. But we can't just randomly pick people out of the population and say, you're in the study jail for a week, because some people don't want experimental things done on them, and that's just fine too. So it's better than just studying on animals, but it's got its limitations in accuracy like that. So then once you have the data, rather than just having a single person look at the data, they tend to have people work in teams in there. By having people that come from different backgrounds in there, people will have different point of views, ask different questions, and the overall analysis seems to be a little bit better that way. So science does play a role in technology. By learning to understand these phenomena, we can then manipulate them to create things that are more convenient for us with technology in there. So I'm going to stop this recording and start a new one so everything in chapter 2 can be all together. It just